All right, so the first question we need to ask is, what is georeferencing? Well, georeferencing is the process of defining an image's location using map coordinates and assigning a coordinate system to the image. Now, if you've used Google Earth or the base maps that are built into ArcGIS, those images are typically always already georeferenced, so you haven't had to worry about that in the past. However, there are tons of historical aerial imagery that's available, often for free, out there on the internet if you look for it, or our local university library here has aerial imagery from many decades in the past for the whole state that we live in hard copy. And they have a scanner, so you can go over there and scan that image. Now, to bring that into GIS, whether you download the image off of the internet or you scan an image, you need to georeference it so that GIS knows the coordinates of that image and can correctly place it on Earth. So here, we have two images side by side to help answer the question about why would we want to do this? Well, we can compare images from different points in time to analyze changes. For example, the image here on the left is from 1948 at a spot in central Missouri in Miller County. And the spot on the right, and the image on the right, is a 2022 image, and you can see that there are changes. The main road that runs north and south here is more or less the same. This small side road that comes in is present in the 1948 image, but you can see there's a whole brand new driveway or road that comes off at this point. There's a new driveway here, a pond up here in the top center part of the image, and several houses and structures that weren't there in 1948. So if we can georeference the image on the left, then we can quantitatively compare it to future points in time to see how things have changed. So let's talk a little bit about the workflow that we're going to go through in this process of georeferencing. In our case, in the example that I'm going to work through today with you, we have two separate images that overlap. This is the way these images were captured. An airplane flew, usually sort of in a lawnmower pattern. It went west to east and then turned around and came back east to west. And it varied its flight path and the rate at which it took pictures so that each picture that was taken overlaps about 2/3 with the previous picture. So to cover our area of interest today, we need two pictures. They're called A1199 Ungeo and A1198 Ungeo. We're going to take both of those images. We're going to remove the collar, the black collar that surrounds the image using the Extract by Mask tool in GIS. Then we're going to georeference these images relative to one another. So this is not the absolute georeference. We're just going to line this image up, the 1199 image, with the 1198 image so that they correctly overlap in GIS. So that will give us a relative georeference. Then we're going to take those two images and use the Mosaic to New Raster tool to mosaic them into one new image that line up correctly. And you can see that here. You can see where the boundary is because of differences in the contrast in the two images. But the images are correctly lined up here. The purple polygon that's shown here in all the images is the stream corridor that we're interested in. And so now we've got an A1198, A1199 mosaic image, and then we can georeference that now to our 2022 base map, which is available online and is already georeferenced. So now what we're going to do is we're going to take our mosaic and we're going to match it up so that it lines up perfectly, or as close as we can get it to perfect, with our 2022 base map. And when we're done then in GIS, we can overlay these layers accurately so that this stream corridor is in the same spot, stacked on top of each other, of these two images. Okay, the first step is to bring our ungeoreferenced historical aerial imagery into GIS and get it roughly lined up. We have two historical images, and all I want to do is get them roughly lined up relative to one another. I'm not trying in this first step to get them precisely georeferenced to our Basemap. That's a future step. So I've got my 2022 Basemap, which comes georeferenced from the source that I got it from, and I've traced the stream corridor out that I'm interested in here. You can see the stream corridor has this big bend that is kind of easy to pick out in other images. So that's what we're going to look for. Oops, let's do this. That's what we're going to look for when we bring in the other historical image. So first I'm going to turn off that 2022 layer and just leave my stream corridor there as a reference point. I'm going to click on the A1198 ungeoreferenced image. That's my first image. Then I'm going to click on the Imagery tab and the Georeference tool, which is in the alignment group. And then I can fit to display. So since this is the image that's selected, that's the one we're working on right now. So I'm going to fit it to display. And what you can see here is that big bend, which is here in the purple polygon, is pretty visible here on the map. So what I want to do is get this purple bend lined up with that same bend in my historical aerial imagery. Alright, so I'm going to zoom back out a little bit, and I'm going to use the Move tool, which allows me to grab that image and get that bend lined up as well as I can. But what I can see here is that the historical photo is not scaled correctly to this stream corridor. So I'm going to click on the scale corridor, or the scale tool, and then I can grab the box here and shrink that down. Go back to the Move tool. This is an iterative process. And work on getting these lined up. I think we need to scale that just a little bit more. Might be a little too far. Move, zoom in a little bit. Use the Move tool. Oh, I think I went a little too far with the scale, so I'm going to make it a little bit bigger. Back to the Move tool. One more try. Alright, I think I have it there. Lined up pretty well. Paying attention to the bend. There's another crook down here in the stream. I think I've got that lined up pretty well. So now that I'm happy with it, what I can do is click the Save. Now this is not saving the project like the Save button up here would do, or the Save button in here, Save Project. This save saves our georeferencing. We haven't really georeferenced this, but just by moving and scaling it, we can hit Save, and that tells ArcGIS that for now, this is where this photo lines up with the Earth's surface. It's not perfect, but it's close. We can save that. We can close the georeference on that image. We can turn that one off, select our other image, which is the A1199 image, go back to the Imagery tab, select Georeference. Now we're georeferencing this one. I'll check it to turn it on, fit it to display. What you can see is our big bend is over here, so we definitely have to move it. Move that over, get it a little closer. See, we've still not scaled properly, so I will adjust the scale a little bit. Switch back to the Move tool. I'm pretty darn close there, but I'm going to do one more scale. Move, and I'm pretty happy with that, so I'm going to hit Save on the georeference. I'm going to close the georeferencing. I'm going to hit save for the project too, since I've made some progress here just in case it crashes so I don't lose it. Now I can turn on both of these layers. And if we zoom in here to where they overlap, this area where they overlap, we can come in, select our topmost image, go back to Imagery, choose the raster layer and the swipe tool. Come in here and it lets us swipe. So what you pay attention to is right where the black arrow cursor is this intersection, and as I swipe that top layer over, you can see that it's not lined up perfect, but we're pretty close. If we come over here, you can see that this intersection where my cursor is right now, not lined up perfect, but close. Just want to check that. Like I said, for this step, it doesn't need to be perfect, just needs to be close. And I think we're there. I'll zoom to layer, and we're ready for the next step, which is removing the collars. Okay, our next step, now that we've got our rough alignment done, is to remove this black perimeter from each of the images. That's called a collar. We want to get rid of that collar before we do anything else. So what we're going to do is come over here to the geoprocessing window, and I'm going to search for extract by mask. Choose that tool, and then we'll do the A1198 raster first, and then we need a polygon here. Basically, we need a polygon that defines the area that we want to crop out. The nice thing about ArcGIS Pro is we can create that polygon right now in the setup for the tool. So I clicked over here and I chose polygon, and then I have different choices here. I'm going to use the first tool here, which is the polygon one. And when I click, I don't want to get right on the boundary between the picture and the collar. I'm just going to be inside it a little bit. We've got plenty of overlap on these images, so it's better if we don't have any black. So I'm just going to stay a few pixels inside the edge of the collar, although I'm not going to worry about these little black indentations here. They're not going to be in our way anyway. Okay, so I'll right click on one of the corners here to finish that. That creates that polygon, and you can see that ArcGIS has added that polygon as a layer to my table of contents. And that is the mask we're going to use to clip. Now here's where I have a chance to save my new raster, and I'm going to change the name here. Come into my Geo database, and I'm going to put a name. I'm using a slight modification, Geo for georeferenced, even though it's not completely georeferenced. This is the copy will georeference and EBM, meaning extract by mask, so that I know that's what I did. We'll leave the default extraction areas inside, meaning we want to crop the area inside the polygon, and then we can run that. It'll take a few seconds while it does its work, and then it will add the new raster to the map. Okay, the extract by mask tool has completed. It was successful, as the message down here in the lower right says. And it has added over here in the table of contents that new layer. So if I turn off the original ungeo layer, you can see that now that collar, I'll turn off the polygon too. The collar for this 1198 image is gone. So I'm going to repeat that process with the 1199, the other image, and we'll be back in a second when that one. Okay, our second extract by mask operation has completed. I'll turn off the ungeoreferenced version and then turn on this, and you can see that we have both of our images now. The collars have been removed, and we're ready for the next step, which is to georeference these two images to one another so that they line up as perfectly as possible. Alright, so before we move forward with georeferencing our imagery, I need to explain some terminology to you. So in ArcGIS, we have control points, and control points are part of the georeferencing process. They're points where we mark a point on the source map, which is our ungeoreferenced image, in this case the black and white 1948 image, and then we go and we mark the corresponding point on the already georeferenced image, the 2022 image on the left here. So what we tell GIS then is we say, look, this red point on this old unreferenced map is the same it's the same point as this point on this map where you already know the coordinates for. So then GIS can make the assumption that, okay, that lines up and this point is the same as that point, and we do this at 8 or 10 spots at a minimum across the portion of the map that we're going to do the analysis on. In this case, we've got a stream corridor, so we're going to try to concentrate our control points within or nearby that stream corridor so that our georeferencing is the most accurate there. All right, checkpoints are a little different. Once again, a checkpoint is a point that we create on both image sets. So we'll create one on the 1948 image and one on the 2022 image. And but we won't tell GIS that these correspond. What we'll do is we'll ask GIS, hey, tell me what the coordinate and latitude, longitude, or preferably in UTM coordinates this point is in the 2022 map, and what's the coordinates for this point on the 1948 map. If our georeferencing were perfect, then when we subtracted the 2022 coordinates from the 1948 coordinates, we'd get 0, right? Because if it were perfect, the coordinates, the lat, long, or the UTM would be exactly the same in both sets of images. Now, no georeferencing is ever perfect. There's always error due to lots of factors that I'm not going to go into here. So when we compare those 2 points, then we can measure sort of the distance apart. It's theoretically that distance from the point on one set of photos to the point in the other set of photos should be 0, but because there's always some error, it's going to be some distance. And let's say it's 1 meter is the difference between points in photo set A and photo set B. Well, that 1 meter then gives us an idea of how accurate the georeferencing is in that portion of the photo. It's about 1 meter. It means that there's at least 1 meter of error there. Now we're going to once again take 8 to 10 of these. We're going to create 8 to 10 of these checkpoints all across our map, and then we're going to average those, and that will give us an overall estimate of the accuracy of our georeferencing. All right, and then let's talk about how we set these control points. As you can see, because of the difference in resolution and quality here, we have to kind of eyeball where these points are going to line up. There's some judgment involved, but if we use a few rules of thumb, we can be pretty accurate in the way we set these points, even across images that vary this much in quality and time. Now remember, like I said, some of the differences between these two maps could be real. It seems to me that this road in 1948 that comes across here makes a little bit steeper or sharper bend here if you were traveling east to west than it does now. I suspect that the highway department, when they paved this, sort of smoothed that curve out a little bit. So what I'm going to do is, it looks to me like in 1948 that there was a section of this road that was sort of straight here and then came up and bent just about where the intersection is. So in my mind, when I'm setting the control point, I sort of follow that line up, and then I try to visualize where it intersects with the north-south road. And to me, that intersection's right in here. So on the old photo, or on the new photo, I can sort of do that same thing. Say, okay, I think the road used to come up, and in fact, if I redrew this red line, I'd probably draw it a little steeper like this. but it comes up in this way and then intersects right here. So I would put that point maybe just a little bit, now that I eyeball that a little more, just a little bit above where I have that intersection drawn there. You can see that angle is just a little different here. But anyway, I'm doing all of this in my head as I set these control points, trying to give my mind some discipline in where to make that click with the mouse between my source and my target photos. All right, now with that, let's go and actually set some control points on our map. All right, so let's do a little georeferencing. Now remember, initially here, we've just roughly georeferenced in a very approximate way our 1198 and 1199 images from 1948. And we're still not going to do a final absolute georeferencing in this step. The goal is to georeference these two images as accurately as possible to one another to get them lined up as well as we can. And then we will mosaic them into a single image, and we'll take that single image and georeference that as a final step to our 2022 base map. All right, so let's get started with this. I'm going to choose my 1198 map, which is the upper one, covers the left side of my screen here, and I'm going to use that as my source, and my target is going to be the 1199 that covers the right portion of my screen here. You'll notice, you can see up here at the top where they don't line up vertically quite 100%, that it's this middle part where they overlap. That's the only part where we can georeference these two together. There's no corresponding point out here in the far left of the 1198 image or the far right of the 1199 image, because they don't overlap in those areas. So we're going to have to find all our control points in this overlapping portion of the map here in the center. Now keep in mind, we don't really care about this part of the map up here in the north. We only care about the part of the map through the stream corridor, because our objective, our purpose, is to do analysis of how that stream has changed over time. So we are going to focus our control points and eventually our checkpoints down in this area so that we get the best georeferenced result here and the best possible georeferencing, the minimal possible georeferencing error down here. All right, so it's helpful to zoom in. I've got my cursor sort of here on the boundary, so this is sort of the far west. You can see right here is a nice intersection. I'm going to zoom into that point, and I'm just going to turn on and off. You can see that on the bottom map, 1199, that intersection's over here, and when I turn the map on, it shifts back. That's because they're just roughly georeferenced. All right, so I've got my 1198 map selected. I'm going to go to the Imagery tab, click on the Georeference tool, and then I'm going to click Add Control Points and Control Point Table. The control point table pops up the table. You'll see as we add control points, they'll populate down here. And then up here in the corner will be sort of a running estimate of our root mean square error, one of the ways you can assess the accuracy of the georeferencing. All right, so let's set our point. We've already clicked on the Add Control Points tool. We always want to do our source, which is 1198 first. So I'm going to zoom in a little bit. And I like to visualize, as I discussed earlier, here's a line that goes through this road that runs northwest to southeast, and a line through the center of this intersecting road. And it looks to me like they sort of intersect right about there. The middle of both roads is what I'm trying to visualize. So I've sent a point there. Now I'm going to turn off that, and I got to zoom back out a little bit. I'm using the scroll wheel. I'm going to grab, I'm going to zoom in, and I'm going to find that same point right about there. All right, you can see that the green and the red sort of merged right there. That's our only control point so far. You can see it added to the control point table down here. Our error is 0 because right now it's only got 1 point, and because it's only 1 point, it was able to align those 2 points up exactly. All right, so I'm going to turn on my 1198 again, zoom out, and I'm just going to head downstream a little bit. I'm going to look for the next intersection. I want to spread these out a little bit, but I'd like to keep them as much as possible along the stream corridor. So here's a road coming in from the south. Now keep in mind, like over here, we've got some dark pixels. Those are probably just a tree that's creating shadows. So look at the overall trend of the road. It's probably a pretty straight road, but there's some trees at the intersection. And I think that's where the center of the two roads meet. Turn off the 1198. I'm going to find that same spot for 1199. I think it's right there. And once again, you can see there's this dark area at the intersection. The camera has moved because by the time the plane took this picture, it's moved further to the east, I think, in this case. And so the plane, from the perspective of the camera in the belly of the plane, we've got a shadow that goes all the way across the road here that comes in from the south. So I'm trying to ignore that shadow and look at where would those two roads intersect. All right, so now we've got 2 points. Zoom back out a little bit. We'll scroll over here, zoom in. All right, so here the road curves up from the southwest and intersects this other road. It's pretty clear. This one's pretty easy and clear. I think that's about the center. Turn that off. All right, so now we've got 3 control points. Our error is still relatively small. That's because there's only 3 points. As we get more points, that error will probably increase because it gets harder and harder with more points for ArcGIS to force them all to line up. Each point has a different error. One might be off a little bit to the east, one to the west, one to the north, and it's kind of got to do its best to fit all of those. All right, so here's another intersection. So that one's okay, but I kind of like this one. I'm going to turn that map off. Okay, so this intersection right here is pretty clear on both maps. So we always do the source first, which is 1198. So I'm going to set that point there. Sort of ignore what seems to be some shadows based on the pixel colors, and I think that lines up there. We've got it now. You can see our error jumped up here a little bit to 1.73, but overall all our errors are pretty good. They're all well below 2.5, and so far so good. All right. Okay, I've been georeferencing since I last spoke to you, so I stopped the video for a few minutes so that you wouldn't have to watch me go through the whole process since it's repetitive. But now we're at the point where I want to bring you back in. First of all, I've got 8 points that are down here in my table that are checked, and that gets my error down to 7 RMS for the forward, a little less than that reverse. But we've got one more trick up our sleeves. First, let's change from a first order polynomial transformation to a second order. These transformations are the different algorithms that ArcGIS can use to make the maps fit one another based on the points you've georeferenced, the control points. So I usually use a second order polynomial. It lets ArcGIS do a little bit more warping and skewing of the map rather than just shifting it around this way. It can twist and make the maps fit a little bit, sort of like a rubber sheet. It can pull and stretch in some parts. That gets my errors down to about 1.27, and I've got sort of the minimum number of about 8 control points. You can see here that really there are 13, but I've got 5 of them unchecked. And what I did is I went through, and I'm going to go ahead and I'm going to check these ones that are unchecked right now. You can see the residual on this first point, link number 10, the residual on that's 13. And we'll highlight that one by clicking on it. So for whatever reason, this just wasn't a really good control point. I tried to use the edge of this field, and field edges are not really great control points. So that one didn't really work out so well. And then somewhere else in the map here, I think up over in this area. Initially I tried this control point here, but once again I'm not sure which one it is. This one gave me 3 meters residual versus this other one was about 9 meters. I even deleted it and redid it at one point, but I think just something is off about this part of the photos. Who knows? I got a better result over here, so I'm going to use that one. And one of the ways you can assess which control points to use, and remember, this isn't just cherry picking your data, at least not if you're being honest about it. I've gone back and reviewed most of these. It's also about thinking, well, maybe just because of the shadows or the pixelation, I can't get that point precisely right here, so it's not a good control point. So you can click on the header column to sort by your residuals. Right now I clicked on the first one. Now as you uncheck one, it recalculates everything else, so you have to keep resorting the column. And now my next best one, or worst one, is 11 meters. And I'm going to pay attention up here. That gets us down to 4.5 meters. And if I look through the list, I'll resort again. See, a lot of these down here are 1, 2, even 3 meters. So I'm going to go ahead and get rid of one more. Sort again. My overall error is down to about 3. I've got 10 points. I need at least 8 minimum, so I can play a little bit here. Let's see. Get rid of this next one. That gets me down to 9 points. Resort. My overall error is about 2.67. Now I've got 8 different points. I'm going to zoom back out for a second. Let those redraw. My 8 points are spread out. Most are along the stream corridor. There are a couple that are close by and adjacent, but not quite in there. And with these 8 control points, I've got my RMS error down to between 1.76 and 1.54. My forward inverse combined is 0.28 with a second order polynomial. I'm pretty happy with that. That's a pretty good result. I would guess, I don't know the exact resolution of these photos, but I would guess that the pixels in these photos are probably on the order of about a meter, which means that my error is 1 to 2 pixels. You can't do much better than that. So now we're at this point where we can do a couple things. First, I'm going to save my overall project before I go any further, just in case. I'm going to export my control points. It'll say, do you want to export only the enabled points? There's no downside to exporting them all, so I'm going to say no, which means that they'll all get exported, even the ones I haven't checked. I'm going to name that control point file. If you're in my class, the assignment gives you a name. It would be your last name, which for last name I'm going to type key, and then that postfix, and I'll save that. So that has saved those control points as a file. So I could re-import the ungeoreferenced image, import the control points using this tool over here, and not have to re-click all those points if for some reason I had to redo it. I'm also going to generate a report, and I give a naming convention for that also. And that creates this table, which is just the attribute table from GIS with all the information about the control points and what our RMS errors are with the 8 check that we were using. So I'll close that. And then finally, I am going to save that georeferencing information, and with that I can close the georeference, which pops me back out to map view here. Now let's just do a quick assessment of the quality of our georeferencing to make sure we're happy with it and that it doesn't have to be redone. So I'm going to zoom in a little bit. Go back to Imagery. Select my 1198 and get the swipe tool started here. I just want to zoom in a little bit. Oh, that's too far over. That's too far over. Let's get into the overlapping space. Okay, so here's where they overlap, and the swipe tool allows me to swipe away the top one and look. And so if you look up here where the cursor is, it's pretty close. As I swipe one image and look at the underneath, they're lined up pretty well. There's a little bit of shift in the road right here. If we look at these light colored fields, they line up pretty darn well, as does this stuff down here. So I'm pretty happy with that. Move up. These ponds over here, whatever they are, those are pretty distinctive. You can see there's a little shift, Not totally happy with that. I want to look at it in the stream corridor here. It's off a little bit as I look at the stream itself, but not as bad as the road seems to be a little bit. Although that could be fooling us because of the perspective of the photos. Okay, so not great there. Let's look at some other spots. Pretty good through here. Trying to keep that cursor near the road. Here's that intersection. I mean, that's almost perfect right there. So that's pretty good. I'm going to look at the stream itself. That looks pretty good. All right, so overall, I'm pretty happy with this. That one spot was a little off. That might just be what we're stuck with, because, yeah, down here looks great. Zoom out a little more, find this far edge. Okay, here's the edge of our 1198 photo. Zoom in a little bit. Watch this road down here. Not bad, not bad. All right, so I'm pretty happy with that overall. So now what we have done is we have tied together our two historical images. The next step is to mosaic those together. So let's do that. All right, our next step is to take these two historical images and merge them into one image. Now that we've got them all lined up, we use the mosaic tool to do that. So we'll go to Geoprocessing. I'm going to search for Mosaic. And the second one down here is Mosaic to New Raster. The difference between Mosaic and Mosaic to New Raster is Mosaic takes the existing raster and just modifies it by adding the other one. If you Mosaic to New Raster, you don't mess up or mess with your originals in case you needed to redo something, so I tend to prefer this. All right, so first we have to tell it what rasters we want to do. We want to use the 1198 GeoEBM, the 1199 GeoEBM. We have to give it an output location. I'm going to make that my geodatabase, and the raster name. I'm going to use the descriptive name A1198 underscore A1199 Mosaic. The spatial reference for the new raster. We want to use the same spatial reference as our Basemap down here, which is NAT83 UTM zone 15. The bit type you don't have to change. It will bring in the existing bit pixel type for the images, so we don't want to mess with that or change it. We do have to give it a number of bands. These are one band images. If you ever were in doubt about that, the way that you can tell how many bands is to take one of the rasters that you're mosaicing, right click on it, click properties, go to source and raster information, and right there it says one band. So we don't want to change that. We want there to be one band. So do that. Now the last is we have this area of the image that overlaps. And if we pick last, then in this case it will be the bottom image is what will be used when the two overlap. Or we can use the first, which means it'll use the top image. And then the color map mode is the same thing if it's going to take the color map from the first to the last. Since we georeference things with 1198 on top, and that's what when we were sort of checking things we were checking on, we're going to use first for both of these so that the 1198 takes precedence when it merges these together. All right, with that I'm going to click run and pause while it runs, and I'll see you back here in a few seconds when it's all done. Oh. Okay, the Mosaic process has worked. It actually crashed on me one time and I just reran it with the exact same parameters and it finished right away. So as with many ArcGIS things, be patient, try again if you need to. But over here you can see we have our original individual rasters. We'll turn those off, and then here's the mosaic. So it's all merged together. This is one item now. It is worth noting here, because we focused our georeferencing down here in our stream corridor, which is the area that's going to be most important for the analyses we'll eventually do. It's kind of skewed up here around the edges, and you can see in this point that this intersection is right there. Nothing's lined up well, but we don't care about that. But it is important when we think about creating our checkpoints in the next step. Just like we didn't put any control points up here, we don't want to put checkpoints up here. We want our checkpoints to also be focused on the stream corridor, because that's where we focused our georeferencing control points. All right, so our next step will come up shortly. Okay, the next step is to georeference our Mosaic historical imagery raster to our 2022 Basemap. Remember, at this point we've georeferenced the two historical aerial imagery rasters to one another, and we've roughly lined them up with the Basemap, but not precisely. So we can use the swipe tool here to look at this a little bit. And you can see over here, actually I'm going to move, it's actually not too far off. If you look about where the cursor is that road. There's an intersection right there underneath the cursor. The current rough georeferencing isn't too bad, but we need it to be a lot better than this for doing the analyses we want to do. So we'll set the control points in a very similar way to what we did before. I'm going to come back to the, I've got the Mosaic image, the for our purposes ungeoreferenced image selected. I'm going to go to Imagery, click on Georeference. That starts up the tool. We'll click Add Control Points, Control Point Table. And this is the same process we used before to do the two black and white images to one another. Now we're going to do it from our Mosaic back to our color Basemap. So let's just find first spot. So it looks like this intersection right here, we can put a control point. Click on that. We'll turn this layer off. We'll come to our Basemap and we'll find that same spot as close as we possibly can. There's our first control point. What I'm going to do now is I'm going to pause while I go through and do 8 to 10 more, and then we'll come back to look at how you finalize the map. So I'll see you in your time instantaneously. Alright, so I've completed 10 control points, played around with my my control point table here, the residuals, to experiment to see what gave me a good RMS. I ended up going with the first 8 I did. I had a really good average here. After 8, I was at 3.43 meters forward and 3.85 meters inverse RMS, which I was pretty happy with. I tried a couple more points, and they only made things a lot worse. They were further from the stream corridor. You can see most of my points here are right along the stream corridor. There's one just a little bit south of it. So I unchecked the two that I didn't like, that I did late in the game, that weren't helping, and I'm happy with this. So it's the same procedure here. I'll export the control points, generate a report. I won't make you watch me do that again since I did it in an earlier part of the video, but the most important thing here is to save the georeferencing, and then we can close the georeferencing and do a quick visual assessment of how this turned out. So I'm going to go back to the imagery layer, raster layer, make sure my mosaic is selected, and then I'll do some swipe, and just like we did earlier, I'm going to zoom in, see how this all lines up. Looks pretty good over there, just paying attention to the roads. Some new roads built there, so we won't worry about that, but that gravel road looks excellent, really. Move to look at some other spots on the map. I'm watching the road and the stream a little bit. Looks good. Looks good over here. Road up here, there's that intersection. Gosh, looks darn good there. Come down. Sort of swipe from this end, looking at the road right here by the cursor. That all looks great. Very happy with this. I've done this several times as I've prepared for this project in this video, and each time I've really had a pretty good result. Looks good down there. Alright, so I'm happy with that. I think we have a well georeferenced raster, but the truth will be told by the error analysis when we do our checkpoints, which is the next part of the video. So see you in just a second. Alright, now it's time to do some error analysis to find out how good our georeferencing was. The first thing we need to do is switch to the catalog view over here in the left or the right pane. We need to create a feature class for our checkpoints. So I'm going to right click on my geodatabase, choose new from the context menu, and then feature class. I'm going to name my feature class Georef checkpoints. I'm going to give it an alias so that it automatically will have a nicer name in my table of contents. We need a point type. We can leave these set to their default. And over here we need to create a couple of fields in our new feature class. The first field will be the we'll call correlation point ID. So I just click there. We want ID. That should be text, which it already is. I'm going to switch it to just 10. It's nice to switch this length to what you need. That way you don't get this really wide column in your attribute table. If you leave it at 255 as the default, you'll get this huge column, and it's a real pain to deal with. So I like to make those numbers something a little more manageable. And then I have an alias for this, and we'll just put that right here, correlation point ID, just a little nicer name. Then we'll click, we need one more field. We'll call this one image name. That can be text also. We'll do the length at 20 characters, and we'll need an alias for that to get rid of the underscore. using these aliases are great because the alias is the name that will actually show up in the attribute table or in your table of contents, and then you don't have to get rid of the underscores and stuff like that from the compliant names that are the real names in your attribute table fields. All right, so then come in here, just make sure this should automatically adopt the spatial reference for the map frame that we're using, and it has NAT83 UTM zone 15N. Got a couple of pages that we don't need to mess with, we just accept the defaults and then finish. And our feature class is created. And then I'm going to, right now, the default color that came in for that is a dark color. I'm going to switch that over here to red so that it's easy to see. And I'm going to change the outline from black to red so it's just a red circle. Probably 10 is a little big, so we'll make that 8, and then I'm going to click apply. It doesn't really matter what color, shape, or size you use. Just something that pops out to your eye is what I find useful. Alright, so we'll come back to the map view, and what I'm going to do is zoom in on a spot here, and then we need to get into editing mode. So I'm going to click on my Georeference checkpoints layer that we just created. I'm going to right click and open the attribute table. You can see our attribute table is empty right now because we don't actually have any features. We'll go to the editing pane, and what we want to do is click create so that it opens up the create features pane, and then it shows us our editable layers. Of course, we want to edit the georeferencing checkpoints layer that we just created, and I want to use the point tool to create points. Now from here, this is very similar to the process we used to create control points, but it is a little different. All right, so let's just make sure here. I'm going to turn off our 1198. I'm sort of focused on this intersection. It looks like that intersection's pretty clear in both images. So I'm coming down here. I think this is my intersection point. So I clicked to set that point. I'm just going to call this number 1. You could make it A or alpha or anything you want. What's important though is that you put the name. So this is the A1198, A1199 Mosaic, and I have a 2 because I had to try that twice. I'm going to copy that while I have it. Control C on that so I don't have to keep retyping that. Alright, so that one's done. Now I'm going to turn off that layer, and I need to put a point in the same spot. So if I come straight down the middle of that road to the middle of this road, I think I'm right about there. So that, whoops, click again. It looks like it set that time. That difference, by the way, is the error in our georeferencing. Whatever that absolute distance is in our coordinate system will be. So this is, we want to number this number 1 because this is the second of the pair, and this one is on our Basemap 2022. Alright, and then I'm going to zoom out, and I'm going to do this in at least 8 more spots. You need 8 to 10 checkpoints. So I'll pause while I finish my 8 to 10, and then we'll check back in after I have them all. Okay, I've set the now 7 pairs of control points. They're here in my attribute table. So the correlation point IDs are 1 on each of the 2 different maps. So really, ideally, you want about 8 of these. So we need to do 1 more. I've kind of scouted around and I found one that I think I like up here, this intersection. So I'm going to set this final point. Oops, I typed that one in wrong, so I can go back and edit one of the old ones. All right, so this would be number 8, and it's on my Mosaic. And then we can turn that off. And right here is that intersection on the Basemap. Get a little closer in. All right, and then we just need to properly label that, and that is Basemap 2022. And I'll just zoom to that layer. You can see now we've got our checkpoints are well distributed across the stream corridor. I wish I could have another one in here, but there's things have really changed in this area. A lot of the roads aren't where they are. Even the bridges have been moved in some cases. So I just couldn't find anything in this area unless I went way out here further than I really wanted to go. And south of here, there's nothing either. So I'm pretty happy with these 8. Another spot I could have done was right here, but let's go with this. All right, so what we need to do then, that flickering is annoying me, so I'm going to turn that map back on, is we need to calculate the distance between each of these pairs. So we want to know what the real world distance is between this spot on the Mosaic map and that same corresponding spot on the Basemap to get our error as we discussed earlier. So let's first, we can check this button right here to finish and commit our editing changes. Go back to the editing menu and click this save. This is not saving our project, this is saving the edits. So say save all edits. Yes, we want to save those. And at that point, we have committed all our edits and saved them. So I'm going to save the project too. So we have that. And then I'm going to switch to the geoprocessing pane. And we need a tool called Near. And here it is. For the Near tool, what we want is our input features will be our georeferencing checkpoints, and our Near features will also be, it could be from another point feature class, but we're going to use the same feature class, so this will search for the nearest point within the feature class and calculate the distance. And because of the spacing we have here, our nearest point is always the corresponding point. You know, it doesn't look like there's 2 points there until we zoom in. And you can see now there are 2. So these 2 are much closer than these 2, even though they only look like one here. They're just bunched up on us because of the overlap. All right, and then we want to check this location box. We want to stick with planar method. And then down here for distance, I would just change that distance name, the field name to distance. These are the names of the fields that will be added to the attribute table. Instead of near, I think it's less confusing in the end to rename these LOC for location, but it's up to you. So now we've got the fields correct, and then our distance unit. So it's going to calculate the distance between these points. We want that in meters. I'm going to enable, this actually changes the attribute table for our feature class. So I'm going to enable the undo just in case we're not happy with the results or something doesn't work right. I'll hit run. This tool goes pretty fast. You can see it's updated down here in our feature class attribute table. It's got the distance in this column for each of the points, each pair. You'll notice that each distance is twice because for the Mosaic correlation point, it's 2.5 meters, to the one on the base map, and it's the same distance back to that other one. So each one gets done twice, but the near tool makes this really easy, so we'll live with that. And the next thing we need to do is get these data from this table out to Excel, so that we can do some calculations. So to do that, we will use the Table to Excel tool. So I'm going to go back to the search. I'm going to do Table to Excel. First tool that pops up here. Our input table is our georeference checkpoints. And then we can give it a location. We can't put an Excel file in a geodatabase, so we need to come out and find a folder to save that in. I'm going to save it in this folder, and I'll just call it checkpoint table. Save. And now that should be done, so I can find Alright, so I found that demo, or my checkpoint table that I created with the Table to Excel tool, and I've opened that file up in Excel. It's exactly like the attribute table down here in GIS. It's just moved all that into Excel. And what we want to focus on is the data in that column. These are our distances in meters, and what we need is an average of these. So you can use the average function in Excel, equals average, open parentheses, select all the data we want to average, close that parentheses, and there is our error, 6.77 meters. The standard I set in the exercise is 7.5 meters. So we're within that. I'd actually like to be a little bit better, but that's acceptable, so we'll go with it. And really, that's the number that we're after here for our error. And with that, we're complete. That's the last thing we need to know in order to do our stream corridor analysis, which will be a different video on a different day. So thank you. I hope this Lightning GIS video was helpful.